Leah here from Leah4sci.com/MCAT, and in this video series, I'll give you a very detailed foundation on the basics that you need to know for forces on the MCAT. You can find my entire video series along with my forces cheat sheet and MCAT practice quiz by visiting my website Leah4sci.com/forces. When you think of forces, the standard equation that comes to mind is F equals ma. When I think of forces, I picture an object that is being pushed or pulled and starts to move or slows down. And that directly applies to the equation because the object in question is the mass, and causing it to speed up or slow down comes from a change in acceleration, positive or negative, and that's how we get F equals ma. But when the average student studies for the MCAT, they memorize instead of understand the equations, and then they have trouble applying it to the passages in the MCAT style questions. Instead, what you need to do is take every equation, not just for forces, but every equation, and break it down into the units and practice deriving every unit. So let's apply this to forces. A force is measured in newtons, which is equal to kilogram times meters per second squared. And we see this from the equation F equals ma because mass is measured in kilograms and acceleration is measured in meters per second squared. But don't stop here. If we have acceleration, that means we can tie forces into the kinematic equations and say that acceleration is equal to velocity over time. So force is equal to mass times velocity over time. Velocity is measured in meters per second. Divided by time is per second because we have to have seconds in the denominator, and that once again gives me meters per second squared. So if force is equal to mass times velocity over time, we once again get kilograms meters per second squared. But you shouldn't stop here. If F is equal to ma, practice solving for a and prove that the units work out. To isolate a, we divide both sides by m, which gives us a new equation that says a is equal to F over m. If F is measured in newtons, which is kilogram times meter per second squared, and mass is measured in kilograms, the kilograms cancel, leaving us with meter per second squared, which is the correct unit for acceleration. This is how you actively practice every equation to make sure you get it, you know how to derive it, and in doing so you'll memorize it based on logic rather than just a whole lot of random equations that don't make any sense. If you're not comfortable with the kinematic equations, visit my website Leah4sci.com/MCATphysics and find my entire series and cheat sheet on kinematics to make sure that you get the foundation before moving on to the rest of the forces series. Let's try a simple problem. Here we're told to find the force on a 1.23 times 10 to the third kilogram car when it accelerates at 3.9 meters per second squared. We're told to find the force, so we know we're solving for newtons, and we can use the standard equation F equals ma. In this case, the mass is 1.23 times 10 to the third kilograms, and the acceleration is 3.9 meters per second squared. First thing you want to do is look at the units, make sure it works out. Force, or newtons, is measured in kilogram times meter per second squared, so we know it's set up correctly, but now we have to do the math without a calculator. 1.23 times 10 to the third times 3.9 is kind of daunting, so you want to simplify the numbers and round it, because remember, on the MCAT, close enough is good enough. So we'll round the mass to 1.2 times 10 to the third, and the acceleration to 4. So now we have 1.2 times 4. 1 times 4 is 4. 2 times 4 is 8, gives me 4.8. Keep the exponent, times 10 to the third, and the units newtons. So the force is 4.8 times 10 to the third newtons. To show you how close we are, on the calculator I got 4.797 times 10 to the third, which is actually 4.8 when you round it. Now let's take this a step further and see how to connect forces with kinematics in this problem. A force of negative 12 newtons is applied to a 2350 gram toy car moving at 8 meters per second. How far does it travel before coming to a complete stop? Let's take a look at what we have. A force of negative 12 newtons implies that the force is going opposite the direction of motion, so we're slowing it down, and that's why it comes to a complete stop. We have an initial velocity of 8 meters per second, and if it comes to a complete stop, we have a final velocity of 0 meters per second. We're asked to find how far it travels, which means delta x's are unknown. We almost have enough information to apply the kinematic equations, except that the 12 newtons doesn't plug in. We have to extract acceleration. So with F is equal to ma, which is equal to negative 12 newtons, we are going to divide both sides by the mass, and that will give us acceleration. So acceleration is equal to negative 12 newtons divided by the mass, which has to be in kilograms and not grams. 2,350 grams has to be divided by 1,000 to get kilograms, or simply move the decimal back 3 spaces for 2.35, which we can round to 2.4 kilograms. The reason we round to 2.4 is that 12 nearly divides nicely by 2.4. We'll use the decimal trick here to move the top and bottom 1 over to the right. If you're not comfortable with this, go back to my MCAT Math series on my website, Leah4sci.com/MCAT Math. This gives us 120, which we'll just look at as 12 times 10 over 24. 12 is half of 24, giving me 1 over 2, and 10 over 2 is equal to 5. Don't forget the negative sign, which gives us an acceleration of negative 5 meters per second squared. Negative implies it's opposite the direction of motion. We'll add negative 5 meters per second squared to our list of equations, and now go back to the kinematic concept of which equation do we use. When we have initial final velocity, delta x, and acceleration, we want to use the time-independent equation that says v final squared is equal to v initial squared plus 2a delta x. Since the final velocity is 0, we'll cross that out, and then start to isolate the delta x, which is what we're trying to solve. We'll bring the initial velocity over to the other side, giving us an equation negative v initial squared is equal to 2a delta x, and then we'll divide by 2a, isolating delta x. Delta x is equal to negative v initial squared over 2a, so let's go ahead and plug it in. We have negative times 8 meters per second squared divided by 2 times negative 5 meters per second squared. The negatives cancel out so that we're going to have a positive value, and then we just have to do the math. 8 squared is 64, divided by 2 times 5, which is 10. 64 over 10 means we can use the factor of 10 trick. Just move the decimal back 1 space for an answer of 6.4. Now let's take a look at the units. Meters per second squared means that we have meters per second over meters per second. So let's distribute that into the equation. The second square cancels, and the meters square, we only cancel 1 because we only have 1 meter in the denominator, which leaves me with a final unit of meters, which is correct for a delta x calculation. In the upcoming videos, I'll cover Newton's laws and then the various forces that you have to know, including normal force, gravitational, tension, static and kinetic friction, centripetal force, and rotational, such as torque. You can find this entire series along with my forces cheat sheet and practice quiz by visiting my website, Leah4sci.com/forces. Are you stuck on a specific MCAT topic? I offer private online tutoring where I focus on your needs to strengthen your individual weaknesses. Tutoring details can be found using the link below or by visiting my website, Leah4sci.com/MCAT-tutor. Are you overwhelmed by the sheer volume of information required for the MCAT? Are you worried that lack of a proper study plan and low MCAT score will prevent you from getting into medical school? My new ebook, The MCAT Exam Strategy, a 6-week guide to crushing the MCAT, will help you formulate a concrete study plan by helping you figure out where you stand now, identify your goals, and figure out what it takes to reach them. And it's yours free when you sign up for my email newsletter at MCATexamstrategy.com. By signing up for my email newsletter, you'll also be the first to know when I have new videos, MCAT study guides, cheat sheets, tips, and so much more. The link again, MCATexamstrategy.com.